So here we're given the expression of a curve, and we need to find the equation of the normal at a given point. So we know that there's a point 0, -1 on the curve, and we need to find the equation of the normal at that point. So to find the equation of a normal, we need the coordinates and we need the gradient. Now the gradient of the normal, this is important, the gradient of the normal is the negative reciprocal of dy by dx for the curve. So it's -1 over dy by dx at the given point. So at the point where x equals 0 and y equals -1. So our first step should be to find dy by dx at that point, and then find the negative reciprocal to find the gradient of the normal. So looking at the curve, because we don't have y equals, we've got y and x mixed together, we need to differentiate implicitly. And what that means is that every time you differentiate with respect to x, something that involves a y, use the chain rule and multiply by dy by dx. So I'm going to differentiate this term by term. So this first term, if I were to differentiate that, it's simply 4 multiplied by 1 over 4 multiplied by y to the power 4 minus 1. So that's my first term. That's easy enough. Now 4 multiplied by 4 is 1, and 4 minus 1 is 3, so I can simply write that as y cubed. Now, because I'm not differentiating with respect to x, I need to multiply by dy by dx. So that's a consequence of the chain rule. So that's my first term. Second term, I've got negative ln y. So the derivative of ln is 1 over, so it should be minus 1 over y. But because this is y and not x, we multiply by dy by dx. So that's my second term. All right, and we're doing this term by term because this is implicit differentiation. Now the final term is e to the power x, e to the power y, and that looks like it's a product. Remember, these are two terms that are multiplied, so we're going to have to use the product rule. So it's going to be the derivative of the first multiplied by the second plus the first times the derivative of the second. So let me get all this out of the way to make it easier to write. So our third term is our product rule. Now, conveniently, the derivative of an exponential is an exponential. So it's really going to be e to the power x times e to the power y. So that's the derivative of the first multiplied by the second, plus the first times the derivative of the second. So it's going to be exactly the same, with one difference, that when I differentiate this, I get e to the power y multiplied by dy by dx. So notice that we've got these dy by dx's, but we need to isolate these. We need the dy by dx's together so that we can find the gradient of the normal. So at the moment, we've got 3 of these, 1, 2, 3. So what I want is to bring all of these together so that we can take them as a common factor. So I'm going to say dy by dx multiplied by y cubed, that's that, minus 1 over y, that's that, minus e to the power x, e to the power y, equals, my term there is unchanged, e to the power x, e to the power y. Now, because I'm looking for this, I can divide both sides by that, and I end up with dy over dx equals, and we have that in our numerator and this term in the denominator. Okay, so that is my expression for dy by dx. But what we want is not dy by dx, we want dy by dx at a particular point. So we need to substitute particular values for x and y. So x is equal to 0 and y is equal to -1, because that's the point that we're given in the question. So we know the coordinates of this point. We just need to then substitute 0 instead of every x. So there'll be a 0 here and a 0 here, and a -1 instead of every y. So if we do that, you can put that in your calculator. I'll attempt to do it myself. So e to the power 0 is 1, e to the power -1. So that's e to the power -1 over -1, that's -1 cubed, minus is plus, +1, minus, that's 1, and that's e to the -1. So that looks like it's going to give me e to the -1 over e to the -1, which is -1. So that's really helpful. We found the gradient, or at least the gradient of dy by dx. We still need to find the gradient of the tangent. Remember, the gradient of the normal is -1 over dy by dx. So the gradient of the normal is -1 divided by this dy by dx. So it's -1 over -1, so that's +1. So that is the gradient of the normal. So the last step is to find the equation of the normal. Now remember, the normal is simply a straight line with a given gradient. So the equation is y minus y1 equals the gradient times x minus x1. And we know y1 is -1 and x1 is 0, and m, well, we just found that it's equal to 1. So we have y minus -1 equals 1 times x minus 0. So y plus 1 equals x. Or you can say, depending on the format they want it, you can either say y equals x minus 1 or x minus y minus minus 1 equals 0. Both are acceptable, so either of these will be acceptable final answers depending on what the question says. If the question says write it in a particular format, then you need to do that. I'm going to leave both. So these are the equations for the normal. To do that, we needed the gradient. The gradient was the negative reciprocal of dy by dx. We found dy by dx by substituting the coordinates for x and y that were given in the question. But we found dy by dx originally by rearranging the expression that we got from implicit differentiation, where we had a product rule, and application of the chain rule. So that's how to find the equation of a normal to a curve at a given point using implicit differentiation.